Today's video is going to be about evaluating limits using direct substitution and exploring properties of limits. First thing we're going to do is take a look at an exploration that deals with finding the limit of a function and establishing relationships between the limit of a function from a numerical standpoint to a functional standpoint. And then we're going to explore how to find the limits of different types of families of functions. And then we will explore how to use properties of limits to find or evaluate expressions. So we're going to start with this exploration that you see here on the screen. And it says, finding a limit algebraically. We want a calculator to complete the table below for f of x equals 5x plus 4. So what I want to do is I want to go to my calculator. I'm going to be using Desmos. And I don't own the rights to Desmos or anything like that. And what I want you to see here is we have a table of values. So we're going to find the limit of 5x plus 4 as x approaches 2. And I'm going to zoom in here so you're able to see a little bit closer. So those are the values that we're investigating around x equals 2. So what I'm going to do is now flip back to my exploration screen here. And I'm going to start filling in the table. So based on the results of the table, we had 13.9, 13.95, and then 13.995. And then over here, we had, on the right side of 2, we had 14.001, I think 14.01, and I think 09. 09 there, 14.9. I'm going to double check my table here. Double check my values here. I'm going to just switch between calculator and Desmos just to make sure. It's a 5. I'm going to make those changes. $13.5, and then I'm going to put my 5s here based on the results of the calculator. So we've completed the table, and it says use the results from part 1 to estimate the limit of f as x approaches 2. Give a reason for your answer. And what I'm going to say is, it looks like the limit would be 14 because the values round close to 14. Just something basic, a basic explanation. And then part 3 says find f of 2. So recall from algebra, to evaluate a function, you substitute in the value of x. So if there's a 2 there, I'm going to put a 2 there and then evaluate that, and I get 14. And so if you notice here, I got 14 here, and I estimated the limit to be 14 here. So I'm going to use both part 2 and part 3 to determine how to find the limit of f as x approaches 2 without using a table. And I'm just going to simply say substitute the value of x you're approaching into the function. Substitute the value of x you are approaching into the function. So based on that, that's a very important development because that leads into how to find limits algebraically. So we use a process called direct substitution to evaluate limits of functions as you approach this particular value. So we are denoting the value we are approaching by the letter C. It's you may see some other conventions like A, but here we can use any symbol we want, but this is the convention for it. And here are some examples of using direct substitution. So to find the limits of this polynomial, all we're doing is substituting 5n for x in evaluating the function. Same with this one, fraction, the number you are approaching, here in this case is -2. All you do is substitute it into the function and evaluate the function at that value, and you get a limit. So here are some properties, okay? The constant function, so to take the limit of a constant function is just simply write down its constant. So the limit of a constant is just itself. The limit of a function, a linear function, all you're doing is plugging the value of c in for x. Vice versa, if you have a power function, just plug in for x. Radical function, substitute, plug in for x, however you want to say it. Here are properties of limits that we're going to use later. What this says is if I take the limit of some number multiplied by a function, what I can do is factor out that number, put it in front of the limit, and then find the limit of the function in question. If I'm adding or subtracting two functions and then taking the limit, it's the same as finding the individual limits of those functions and adding them together. If I'm multiplying two functions and then have to find the limit, that's the same as finding the limit of each function and multiplying them together. If I am finding the limit of a fraction or things divided as x approaches c, all I have to do is find each individual limit, find the limit of the numerator, find the limit of the denominator, and divide the two. We do have to place a restriction on g of x because we're in a fraction, so you don't want g of x to be 0, okay? Because if g of x equals 0, then we have to start talking about other types of limits. But right now, we're just going over the foundational parts of limits. And finally, we have a power function here to take the limit of a function raised to a power. As x approaches c, just take the limit of the function and then corresponding power. So now we have some more types of functions. Polynomial functions. We can take the limit of some polynomial function as x approaches c equals p of c. And we can take the limit of rational function, just like we talked about before, as x approaches c. And that gives us these values here. Okay. Deleted the wrong page. Okay, so now I'm going to work some examples on finding limits. So again, based off what we talked about here, we're going to find the limit of each of these. So substitute the value you're approaching. So in this case, it's -3. Substitute it in and evaluate it. That gives you 81. Here, the same thing. Substitute the value you're approaching into your function. And here, same thing. The value I'm approaching, I'm going to substitute it in for x. Now, if you want to leave it like that, it's fine. There's actually a cubed root to that. So if you don't remember, that's fine. So these are basic examples, basic ordinary functions that I just found the limits of and plugged in. So if you understand these three problems, then you can do these practice problems. I already have the answers that I actually computed these and wrote these answers down. So you can use these to check yourself. If you feel there's an error, please feel free to contact me. So we're going to move on to composition functions next. So to find the limit of a composition function, f of g of x or g of f of x, all you're doing is take the limit of the inner function, and then whatever that is, you're going to evaluate that outer function, in this case here, f, at the limit of g. A similar argument, if you're going to find the limit of g of f of x, you're going to evaluate the limits of f as x approaches c. So whatever the limit of f is, you're going to evaluate the outer function, which is g, at the limit of f as x approaches c. So here's an example dealing with composition. Okay, so first I'm going to find the limit of f of g of x as x approaches -3. First thing I do, take the limit of the inner function. So that's 9. And now I'm going to evaluate f at the based on the limit I got from g, I get 16. So the limit of g of f of x is 16. For the limit of g of f of x as x approaches 4, I first evaluate the limit of f as x approaches 4. That gives me 11. And now I evaluate the function g using the limit and that's going to give me 121 as the limit. So if you understand how to evaluate these composition functions, then you can do this practice problem here. Okay. Again, I worked out the answers, and these are the responses I have. You can check, and if you get something different, again, please contact me. Okay, the last part of evaluating limits using direct substitution is using the properties of limits. Okay, so here you see on the screen there's two limits here. One is in blue and the other one's in a light purple. And what you're asked to do is to evaluate each of these limits. So I'm going to start with this one right here. So what I want to do is factor out my 4. Utilize the property. And I get my answer. Going over here to this limit, this is the limit of a product. So what I want to do is write it as a product of two limits. I want to substitute my values in. So you get 6/4. You can also reduce this to 3/2. It's also equivalent as well. Next is the limit of a sum. I'm going to write it as the sum of two limits. And then I'm going to substitute in my values. And so when I evaluate this, I get 11/4. And then finally, I have the limit of a fraction. That's equivalent to taking the limit of numerator and denominator. When I divide these, I'm actually going to be multiplying by the reciprocal, and I get 8/3 as my limit. Okay, so before we proceed, I just want to make sure we understand the work here, because it may seem elementary to you, but you actually need to make sure you are paying attention to the process. So of course, you know, you're going to have to get the answer, okay? But also you want to make sure you're showing the properties of limits in preparation for the AP exam that's going to be given in May. So again, it's not about necessarily the final answer. It's more so about how you got there, the process. So if you understand how to do this example, you should be able to do these. And again, I have the answers or the responses that I got written here of how I worked it. So your job is to, or the objective rather, is to, you know, show the work that will lead to the answer. Okay. And that is all for direct substitution. Okay, that is all for direct substitution. If you have any questions, comments, or concerns, please feel free to email me. Thank you so much and enjoy the rest of your day.